All right, page 186, number 20, says a baseball diamond is a square with side 90 feet. A batter hits the baseball, or hits a ball, and runs toward the first base with a speed of 24 feet per second. Part A, at what rate is his distance from second base decreasing when he is halfway to first base? Okay, so they gave you a picture there, so you can just use their picture. So you have a diamond, it's a square. Okay, and then this is the outfield out here. So and then it tells us that that is a square with side 90 feet. So from here to here is 90 feet. Okay. And it says a batter hits the ball and runs toward first base with a speed of 24 feet per second. Okay, so if he's running toward first base with a speed of 24 feet per second, so we can call this distance that he's, and it says when he's halfway, is that what it says on that first? At what rate is his distance from second base decreasing when he is halfway to first base? So let's think about the runner hits the ball and he's running this way. So let's call the distance that he is away from home plate, this distance here, to wherever he is, because that's going to be changing, right? So we're going to call that X. So part A is when X equals half of the distance. So what is half of 90? 45. Okay. So so the batter hits the ball and runs toward first base with a speed of 24 feet per second. So what does that speed refer to? This distance, how fast this distance, how fast he's moving is the derivative of that distance with respect to time. Okay? So dx dt is equal to 24 feet per second. Okay, so part A says, at what rate is his distance from second base decreasing when he is halfway to first base? Okay, so when he's here, second base is here, right? So what we're looking at is his distance from here to here. So we need to call that something else. So we'll call that y. Okay, so what we want to know is that rate, dy dt. That's what we're looking for. At what rate is his distance from second base decreasing when he is halfway to first base? So I need to find a formula that will relate x to y. Okay? So what do I know about these angles since it's a square? Right angles. Okay, so if this distance is x, what is this distance over here? The total distance from home plate to first base is 90. And so what is this distance here? If he's run x feet, how many are left? 90 minus x. Okay, so this distance is 90 minus x. Okay, so using a right triangle and 90 minus x and y, what is this side over here? 90 also, because it's a square, right? Okay, so how can I relate those all together then? 90 squared plus what? 90 minus x. Y is the hypotenuse, right? Because it's across from the 90-degree angle. So leg squared plus leg squared equals hypotenuse squared.
And you want to use 90 minus x as opposed to 45, or
Yes, because we don't plug that 45 in until we get the derivative part set. Okay, because that's the specific, at that specific moment. So we do the derivative like as a formula for that, to where I could plug in an x value at any point along there and find the rate. Okay? So we'll plug that 45 in after we do the derivative. Okay, so this is the formula that compares, or that relates the y to the x. So then 90 squared is 8,100. And then this is 90 minus x squared. So 90 minus x times 90 minus x equals y squared. So 8,100 plus 8,100 minus 90x minus 90x, so minus 180x plus x squared equals y squared. And then combine like terms, and I'm going to change the order, so this will be x squared minus 180x plus 8,100 plus 8,100 is 16,200. Okay, so that's just the formula that relates the x and y together. Now take the derivative of both sides. Okay, with respect to t. Of x squared minus 180. So I'm going to pull the constant out in front and then take the derivative with respect to t of x plus the derivative with respect to t of the constant, which is just going to be 0, but I'll go ahead and write it, plus the derivative, or equals, sorry, equals derivative with respect to t of y squared. Squared is going to be what?
2x. What's next? Dx dt, because we're taking the derivative with respect to t, not x. So dx dt. Okay, and then minus 180 times dx dt, good. And then plus the derivative of a constant is 0, so that's gone, equals the derivative with respect to t of y squared, 2y dy dt. Okay? All right, so after you do the derivative, that's when you plug in the specific values. Okay? So when x is 45, so I'm going to plug in 45 for x. And we were given dx dt, which is 24. And this is feet, and this is going to be feet per second. Minus 180 times, again, dx dt, so 24 feet per second, equals 2. Do we know y? Can we find y? For a specific value of x, can we find y? Yes, so think about that triangle. We have 90. X is 45, so what's 90 minus X? 45 also. So then 45 squared, so this is Y. 45 squared plus 90 squared equals Y squared. So what's that going to be equal to? 10,125. And then equals Y squared. Then take the square root of both sides. So what does Y equal?
You want the decimal?
Yes.
100.62.
Okay. And that's feet, right? All right, so when X is equal to 45, we plug all of that into this triangle and solve for Y. We get Y is 100.62. So now we can plug that in here. 100.62 feet. And then dy dt is what we're looking for. All right, so multiply 2 times 45 times 24. 2160. Okay, and that's feet squared per second. Minus 180 times 24.
Negative 2160. Oh, we'll make that.
4320.
4320. Okay. Should that be feet squared per second?
Yes.
It's 24 feet per second. That's 180. Is that feet? Okay. All right, so feet squared per second, and then equals 2 times 100,
201.24.
24 in feet, and then that's dy dt. Okay, so over here, 2100 minus 4320 is what? Negative
2160.
2160? Okay, and that's feet squared per second equals 201.24 feet times dy dt. We're solving for dy dt, so divide by 201.24 feet. Okay, so we get negative, and it's going to be feet per second, 10.73. Okay, so what does that mean, what we just found? Okay. So this distance, when he's 45 feet away from home plate, this distance from here to second base is decreasing by 10.73 feet per second as he's running. Okay, so that's what it's telling us. All right. Any questions on that? This one came from the Y value that we found in this triangle over here.